Hello friends, welcome. Friends, we are all aware of that currently the Chinese DeepSeek AI model has shaken the AI industry and everybody is running all over the place confused that what is going on in the investors, the countries, the political, the hierarchy of the country are now all concerned that whether China is getting a head start and whether it is going to become either a unipolar or a bipolar world depending upon who has the edge on AI development, means AI technology. So Indian government also got concerned and now they have started the process of developing our own AI model, right? So friends, why I'm doing this video? The reason I'm doing this video is to understand that what kind of challenges and opportunities that we will face as India in this path of development of AI model. That's the whole point about this video. And in order for me to describe and list those challenges, I have taken help of this guy who is the Anthropic CEO, and his name is Dario Amodei. I don't know how to pronounce his last name, so just bear with me. So I'll just go with Dario. And he has written an article. And then this article, he has laid out the philosophy of development path of AI models, the artificial intelligence. And looks to me, this article is pretty important for everybody to read. And that is why I am doing this video, because if you go through this article, what he has written, right? And he has recently written this article maybe a couple of days back, and it has been captured in various newspaper articles, dailies. And here in this article, the point that he is raising is absolutely relevant and it resonates with me because I have seen this semiconductor industry and the operating system which runs on the semiconductor industry in Windows, laptops and mobile phones evolve over a period of time. So it kind of resonates with me very clearly, and therefore it is important for me personally to understand what he is saying. And what I did was I took a PDF version of his writing and underlined it word by word so that I can talk through this in this video so that the viewers can benefit from his writing, because this guy is a pretty important guy and he has worked in OpenAI. So let's go and understand what he's saying. He is saying that there are three dynamics of AI development, actually three stages of AI development, right? He is calling it dynamics, but I understand that there are three stages of AI development. So he is calling this as the first dynamic is scaling laws. The second dynamic is shifting the curve, and third dynamic is shifting the paradigm. Now I'm underlined and people might be seeing that I have gone through it with very closely and underlined each and every word. Let's understand this first and then we will look into the DeepSeek model, what he is describing and what stage of development cycle it is. Then only we will understand what is going on and how India is going to go through this curve, these challenges, or you can say the three dynamics of AI development. That is the important part of this video. Now, what is scaling law? Scaling law we have seen in the semiconductor industry. It follows a Moore's law. Everybody knows that the power of computing keeps on increasing or doubling each and every after a certain period of time, right? That's called Moore's law. And Moore's law has been used to predict the performance of chipset in the telecom industry and in the computing industry for a long period of time, right? And as the chips become more powerful, then what happens is the operating system which is overlaid on those chips also become very, very powerful and capable. We have seen that, right? It happened in mobile industry. It actually happened in the laptop industry. It is now happening in the mobile industry. Now, this is a very important point which is to be noted here, that this scale at which this development cycle works is disproportionate. It is actually exponential from the point of view of money spent versus the gains are linear in nature. So what does it mean? Suppose, let's say if I draw a line like this, let me just draw a line. So this is the gain, right, of the capability of AI model. Okay, this is the line. But if you want to spend money in order to deliver this gain, then your money spent is going to have to follow an exponential path. in order for you to get a linear path towards more capability or more power of those AI models. So the smaller models will require you to spend less amount of money, but it will solve problems which are on a lower scale of capability, which is, let's say, $1 million spent, 20% of the important coding tasks will the model will be able to solve. Now, if you spend 10 times the money, then the gain is linear, 40% only. But if you spend 100 times the money, then again there it is a linear scale, which is 60%. Do you understand now what is going on? So this is the scaling law he talks about, that in order for you to achieve a model which is par with 100% of the problems that he will solve, the money that you have to spend is going to be exponentially high compared to a linear scale of gain, which is called the scaling law. So this is first part of his article. Then it says shifting the curve. Now what does shifting the curve means? Shifting the curve means that if you are going to have a curve, right, which is a linear line first, let's say the line of performance of AI model, and then on top of which you overlap the money curve. So you come out with a graph where the money and the path of growth of AI models are superimposed with each other, right? But there is an x-axis and there is an y-axis here, like that. Now, this whole graph, which is on the x-axis and the y-axis, you can shift it upwards. Shift it upwards like this. It will shift. That is called shifting of the curve. This is what is being talked about here, shift of the curve. Now, what is shifting of the curve? Shifting of the curve is similar to what we saw in the computing industry. What does it mean? It basically means more computing power, right? The chips becoming more and more powerful. And the operating system also caught up with the power of the chip. And as we grew our computing industry and made the computing industry better, you saw that whatever capabilities that we were able to deliver on a chip of lower, processing power, now we are able to do much more. For example, supercomputers of the past used to capture the whole room. Now you have the same capability right on your mobile phones, right? Which you can do multiple things much more than what the supercomputers of 1970s or 1960s were capable of. So let's read what he's saying here. It is very important. The field is constantly coming up with ideas, large, small, make things more effective and efficient. It could be an improvement to the architecture of the models. One is that the architecture of the model can be improved. And then it says that or simply way of running models more efficiently on the underlying architecture. So architecture of the model is what? The operating system. And simple way of running architecture of the model is what? The analogous thing will be the power of the processor of the AI industry, and the simple way of running the model efficiently under the underlying hardware, right? So basically this is making the operating system much more capable of being able to extract the power of the chip on which the model runs. So he states the shift of the curve, and further elaborates on it, is saying that shift of the curve means if the innovation is 2x compute multiplier, then it allows you to get a 40% on a coding task for 5 million instead of 10 million. So what we saw here, we saw 1 million, 20%, right? 10 million, 40%, 100 million, 60%. So what he's saying, if the curve shift, then in 5 million, right, you will be able to get 40% instead of 10 million. Right, instead of 10 million, right? So that is what he's saying, right? Because here you saw 10 million, 40%. So now you were able to do it with only 5 million. So this is the concept of shifting of the curve. Then he goes on to say that this curve has been constantly shifting. On an algorithm-based progress has been 1.68 times gains per year. That's what he's saying, right? From an algorithm point of view, means the operating systems are becoming more and more, the models, the algorithm of developing these models are becoming more and more powerful. And he has already stated this in 2020 in his paper. And he says that probably sped up, if probably sped up significantly, it does not take efficiency and hardware into account. If the efficiency of hardware is taken into account, then I would guess the number today may be as high as 4x per year. Means the models and the capability of the whole AI system development is going to become much better, 4 times much better what it used to be, 1 year back, right? So this is the other dimension. Then we have the shifting of the paradigm, and this is very, very crucial. So first we saw that the scaling is non-linear. More money is required to be spent for models which are much more capable, and the capability has a linear scale of increase, whereas the money is exponential, which we saw. And then we saw that both the computing as well as the algorithms are keeping on changing, which will shift the curve upwards. Then we are talking about shifting the paradigm altogether. Means the conceptually the models may follow a different path of development. And what he's saying is that initially the model basically followed a pre-trained concept with a little bit of post-training. So whenever a model is developed, the first stage is pre-training. Right? Pre-training means that you gather all the data of all the internet and then train the model on that data, which is nothing but doing a prediction of what comes next. So there is a language, so you feed in a token, which is nothing but a chunk or you can say that a prompt, which has got a set of words, and then you ask the model to predict the next set of words depending upon the prompt that you have given. So they put a probabilistic, analysis, and it is able to predict the next set of words depending upon the mathematics which have gone in. Means the weights of the models have been properly tuned in order for you to give a accurate analysis which is based on context and the prompt that you are given. Now what he is saying is that after that first stage of model has been prepared, then you have to refine the model by doing post-training. And that post-training has been reinforced with the idea of reinforced learning. So initially the post-training work was done by humans. They used to sit on the computer and they used to give the model specific tasks to fulfill, and they used to gauge the output and then refine the output. So one of the important ingredients in post-training was the involvement of humans. Now this reinforced learning has changed the whole thing upside down. Now the model learns by itself on the post-training phase of the development. So it is saying that this post-training has shifted the paradigm. And that is where the maximum focus has been as far as the current cycle of development, which is in the year 2024. It is not just DeepSeek model. Everybody is actually having this idea of improving the post-training phase of the model development. That's what he's saying, which means shifting the paradigm. Now he says, now you look at what DeepSeek has done. Now what DeepSeek has done, DeepSeek actually had various levels of model development. One was, which came out 1 month before this current model, which is R1, which was announced, which is DeepSeek version 3. So here he says that the innovation, which kindly caught the attention of the public, was much more fundamental and important when DeepSeek version 3 was announced. The R1 version of DeepSeek is not that kind of, you can say, an event to have caught that much amount of attention. The attention should have been caught at the time DeepSeek version 3, which is a pre-trained model. It is not a post-trained model. What they have done, what Chinese companies have done, they have evolved they have all the 3 stages that we spoke about here, the scaling laws, the shifting of the curve, and the paradigm shift, which we spoke about here. So he is saying that the DeepSeek version 3, which is purely a pre-trained model, it is not a post-trained model, they have improved these processes significantly, so that they have the model actually got developed at a cost which is much more cheaper compared to the earlier model which was developed by OpenAI in previous years. And it is following the same cycle of path of development which which has already spoken in his article. So he's saying DeepSeek 3 version 3 was a pre-trained model. The first stage described in 3 above. Then last week they released a paper R1, which is the second stage. So what he's saying that 3 dynamics work can help understand DeepSeek current release. About a month ago DeepSeek was released, and then it says that the real innovation was actually DeepSeek version 3. DeepSeek version 3 was the actual real innovation, and what should have made people to take notice a month ago, and many people actually did, including himself. Then he says that and he points out certain innovation here which I don't understand, so I will just leave it here for people with knowledgeable people to go and read the paper and understand it. And he's saying that the post-training part, which is a reinforcement learning, is a process which other people have been working on. It is not the great innovation. The great innovation was DeepSeek version 3, which was a pre-trained model, right? So what he's also basically saying is that whether it took $10 million, whether it took $6 million, the point is not that. Because every AI development path will follow a innovation cycle where the cost of developing the model is going to keep on reducing with time because of improvement in hardware as well as improvement in algorithm. So that's not the point. But what DeepSeek did is that it actually went on the path of development cycle and created a model which is the pre-trained model much more efficiently, right, than what OpenAI did earlier, because it was the initial path of the development cycle. And then it used reinforcement learning, which is the current paradigm in AI development model, which is called post-training, to make the model more accurate. That is what DeepSeek did when it launched its version 1, right? So what, if you look at this line, what he's saying, all this to say that DeepSeek version 3 is not a unique breakthrough or something that fundamentally changes the economics of LLM. This is important, right? And he also goes on to say that whether they used the NVIDIA chips or not is a question that needs to be understood, and we don't have the answer to it. And people are raising question whether they actually did it in this much cost and that much cost. But the question is not that. He's saying that there's nothing surprising. More chips, more power, more powerful model is going to come up because the cycle of development cycle will remain the same. So if you read this, it says R1 which is the model which was released last week, which triggered an explosion in public attention, included 17% decrease in NVIDIA cost price, is much less interesting from an innovation or engineering perspective than V3. It adds a second phase training called reinforcement learning, as described in 3 previous section, and essentially replicates that OpenAI is done with O1 that appear to be a similar scale with similar results, right? So then he basically goes on to say export control, and I'll just summarize this section very, very clearly without going through all the details, and you will understand the implication for India. What he's saying is that when people say that the chips are not going to be required, is completely a misnomer. You will continue to require GPUs and more capable GPUs for you to able to develop models at par with US and other countries or China, who are already forefront of the development cycle. Without this chip, you can't. You may have the best of the algorithm, but both things have to tie together. The chips as well as the algorithm has to tie together to be path of the to remain in the path of the development cycle. You can't just do it with one, and you will need more money. Because what will happen is that as your models become more and more powerful, the value of intelligence is so much, because today whatever intelligence that we have can be pegged at a certain dollar value. But let's say that the intelligence value increases linearly with time and you get more power and more capability through this AI model. All the investments that you have done on those server farms and the chips will absolutely, with no time, is going to be used to make the model more powerful. So if India really wants to develop models which are at par with what China has done, what US has done, then it needs not only brains which can drive algorithms, to make the model much more capable by following the same development cycle that we spoke here, all the 3 development cycle, but will also require hardware. And that's why he's saying here, if you look at this particular title, export control, he's saying that for US to remain ahead in this particular curve, the hardware industry, which US has nurtured, right, which is developing this GPU, they need to closely protect it. Now, if the hardware industry has to be closely protected and they don't want these chips to get seeded into the world, and he's saying that undemocratic world, which is a different political connotation, I don't want to get into it, US definitely would not like these chips to be, in the hands of countries like China as well as India, right? Because US knows India has got the capability. Now, if these chips are not readily available to India, then we may have, the best of the brains here. We will not be able to catch up with countries like US, who not only has the brain, but also has the chips, which are improving with time. And that is the point, friends, which I want to make in this video. Though India has got very, very, excited about this Chinese announcement, I don't think it is going to be an easy path, because it is not just about developing models. It is actually about investing in those chips. Not only investing, but getting access to those chips. India has got 2 different problems. Their AI budget is very, very small. It's roughly around 500 crores of rupees, and we have to see in the new budget how much they increase. 500 crores of rupees is peanut compared to what US is planning to do, $500 billion. So we have 500 crores rupees and $500 billion. And then getting access to those chips is going to be a huge, huge challenge, because US is not going to let go their chips. And he also goes on to say that yes, some of the chips might have leaked into China through smuggling. He's saying that, look, DeepSeek does not know, it does not show how China can always obtain chips via smuggling, or controls always have loopholes, right? Or that controls always have. I don't believe that export control were ever designed to prevent China from getting few tens of thousands of chips, or a $1 billion economic activity can be hidden. But it is hard to hide $100 billion or $10 billion of economic activity through smuggling, because people will get exposed and people will come to know that these chips are getting smuggled. So imagine the kind of scale that he's talking about. Imagine the kind of investment that he's talking about on the path of artificial intelligence. Because these models are going to become more and more powerful. These models are going to become more, and the algorithms are going to be more and more capable. But the investments in this chip is not going to stop. There will be exponential increase in investment in the technology of this chip, as well as in the models, on the algorithm capability of this AI model. So the summary of this discussion is very simple. Whatever we saw with China did at a lower cost is not surprising, because it followed the same path of development of technology, which is always like scaling laws, shifting the curve, and paradigm shift, which we have seen in past. We have also seen that the algorithms have become more and more powerful, but it has not shied companies to make investment in hardware. They have continuously increasing the hardware capability, and AI is going to follow the same path. Now, if you can somehow block the hardware access to other countries, and if the US has continuously keep investing in hardware as well as software capability, then countries like China and India is going to face a huge challenge to catch up with any of the work that US is doing. That's the genesis of this article. And that's why he's saying, if you look at this title of this article is saying on this DeepSeek and export controls. So he's emphasizing on the word export controls. And that is the reason why I did this video, to kind of tell everybody that just because we get excited in developing an AI model, a local AI model, we will never be able to catch up on the overall development cycle of AI and make AI model as powerful as the US companies will do, because they have both the chips and the brains together, and both of them is going to synchronize and resonate with each other to drive models which are going to be much more powerful than anywhere else in the world, because both aspects of development cycle are going to be required. the chips as well as the algorithm. Both have to work together in order to drive AI development to the next phase of development, which is called artificial general intelligence. That's where we are heading. Whether we will get artificial general intelligence or not, that's a different point. But the models will become much, much more capable than what we are experiencing today. So I hope, friends, you have understood what is the point of this video and why this paper is very, very important. So thanks for your time for listening, and I'll paste a link of this paper in the description. I'll come back with a new video next time. Thank you very much.